So we're still looking at different types of identities. The next type of identity we're going to look at are double angle identities. So if you have sine of 2x as opposed to sine of x, so we basically are doubling the x, cosine of 2x or tangent of 2x. So the identities are listed here. Notice that with cosine, we have a couple different ways we can rewrite it. All we're doing to get this is we're substituting cosine squared with 1 minus sine squared and sine squared with 1 minus cosine squared. So just doing a little bit manipulating with that Pythagorean identity. That's why there's so many with the cosines. So we're going to look at a couple different things. We're going to look at, can I just evaluate an expression that's a double angle? And then can I solve with a double angle? So if I want to know what sine of 2x, given that cosine of x is 3/5, and I want to, what I can go ahead and do is I can go ahead and use my formula. Sorry about that. I can say sine of 2x is equal to 2 times sine of x times cosine of x. Well then, notice that in order to evaluate this or determine what it is, I need to know what sine of x is, and I was only given cosine of x. But if you recall from previous units, if I'm given one trig function, I can find the rest of them by using a right triangle. So here's my right triangle. Let's say this is my x, and cosine is my adjacent over my hypotenuse. I can now use the Pythagorean theorem, except I recognize that this is just a 3, 4, 5 triangle, so I'm just going to go ahead and fill in the 4. Now I know that sine of x can be replaced with 4 over 5, so I get 2 times 4 over 5 times cosine of x, which can be replaced with 3 over 5. Multiplying straight across, 2 times 4 is 8, times 3 is 24 over 25. I can do the same thing with cosine of 2x. I can choose any of the above formulas to use for cosine of 2x. One isn't necessarily easier than another. The second one is nice if I only know cosine. The third one's nice if I only know sine. Since I know both sine and cosine because I've already drawn my triangle here, I'm just going to go ahead and use the first one and say that cosine of 2x is cosine squared x minus sine squared x. Well, cosine of x is 3 over 5 squared minus sine of x. We've already saw that is 4 over 5. I'll square that as well, giving me 9/25 minus 16/25. I already have a common denominator, so I go ahead and subtract my numerators, and I get negative 7 over 25 for my value of cosine of 2x. Finally, looking at tangent of 2x, I have one formula to use. It's 2 times tangent of x over 1 minus tangent squared x. So I haven't found tangent of x yet, but going to my triangle here, all I'm going to do is take opposite over adjacent, SOHCAHTOA. So opposite over adjacent is going to be 4 over 3. So I'm going to get 2 times 4 over 3 all over 1 minus 4 over 3 squared. Well, that gives me 8 over 3 all over 1 minus 16 over 9. I can clear those little fractions out by multiplying top and bottom by my least common denominator. So remember, this is called a complex fraction, and I can simplify complex fractions by multiplying top and bottom by the least common denominator of my smaller fractions. Well, my smaller fractions have a denominator of 3 and 9, so I know the least common denominator between 3 and 9 is 9. I can now go ahead and multiply on top, and on top my 3 is going to become 1, my 9 is going to actually become 3, giving me move that over just a little bit, giving me a value of 24 on top. On the bottom, I distribute that 9 in, and I get 9 minus, when it distributes to this second term here, the 9s will cancel. So I get 9 minus 16 on the bottom. Reducing, that's going to give me 24 over negative 7, because it doesn't matter where the negative is. I like to put it on top. I think it's kind of weird to have it in the bottom, but it doesn't really matter. And there's the 3 values that I was able to solve for, again using those formulas. I also have 2 solving examples, so let's take a look at those next. So now I want to go ahead and solve with my double angles. So I'm going to go ahead and say that cosine of 2x equals negative sine squared x. So one thing I could do that we've done in the past is try to replace sine squared x with a function involving cosine, but the problem is it would be a function involving cosine of x, not cosine of 2x. So for that reason, I'm going to go ahead and manipulate cosine of 2x. So when I look up here, since the right side of that equation only involves sine, I'm going to choose to change cosine of 2x to 1 minus 2 sine squared x. And then I will have an equation that deals only with sine values. So cosine of 2x I'm going to replace with 1 minus 2 sine squared x equals negative sine squared x. And now from here, I notice that these are like terms, so I'm going to go ahead and I'm going to add this 2 sine squared x to both sides, giving me 1 equals a positive 1 sine squared x. I'll take the plus or minus square root of both sides, so I'm going to end up with plus or minus square root of 1, which is just 1, equals sine of x. So I'm going to ask myself, between 0 and 2 pi, when does sine equal either positive 1 or negative 1? And I see that it equals positive 1 at pi over 2, and it equals negative 1 at 3 pi over 2. And those are my only two solutions in my given interval. Let's go ahead and look at one more example with solving. So now I'm solving for all solutions, so I'm not stuck in an interval. And I'm solving for all solutions of tangent of 2x equals 2 tangent of x. Well, I know that these are not like terms because this left side has a 2x where the right side only has an x. But I know there's a formula for tangent of 2x. So I'm going to go ahead and change tangent of 2x to be 2 tangent of x all over 1 minus tangent squared x equals 2 tangent of x. I don't like having the function I'm trying to solve for in the denominator. So to get that out of the denominator, I'm going to go ahead and multiply both sides by the binomial 1 minus tangent of x. And they're going to cancel on the left, but on the right I'm going to have to distribute. And I'm going to end up with 2 tangent of x equals 2 tangent of x, when I distribute to the 1, minus 2 tangent squared x when I distribute to my back term. So I'm going to go ahead and collect all my tangents on one side, and then maybe I'll be able to do some factoring. And actually, one of my terms is just going to go away, so I'm not even going to need to factor. I'm actually going to solve this with square roots. I'll divide to get rid of the 2, and I'll be left with 0 equals tangent squared x. I'll take the square root, and actually before I take the square root, I realize that this right here was tangent squared, and I copied it down as just tangent. So I'm going to grab a different color and go through and correct that. So this should have been tangent squared, which would have made this tangent cubed when it distributed, which would have remained tangent cube. It doesn't change my problem too much. Now I just take the cube root to get rid of the 3, but taking the cube root of 0 is still going to be 0. So I ask myself, when does tangent of x equal 0? So in other words, when does sine of x over cosine of x equal 0? Which means when does my numerator, when does sine of x equal 0? Well, the first place that sine equals 0 is at 0. Because the period for tangent is pi, I don't have to list the second one. I can just say 0 plus pi n. So x is just going to equal pi n. There's going to be all my solutions, my general solution. So once again, not necessarily learning anything new, just expanding to include more identities. So again, please bring in any questions you have with you to class so we can talk about those before you do some practice on this.